Okay, so now let's learn chi-square, sorry, t-test. Okay, let me explain. Like I told you, I will always tell you when to use any of these tools. So you have to be conversant with their uses. Let's, when they produce, currently we have different COVID-19 vaccine. They produce the first one, or let me use, okay, let me use COVID-19, and I will use other diseases. You can mute yourself. Emmanuel, can you mute yourself? Okay, thank you. So they had the first COVID-19 vaccine, and they discovered that if, example, I'm just giving, not that that's what happened, it's just an example. They discovered that after vaccinating people, 5 or 10% will still contract COVID-19, while 90 will not contract. Another producer may look at it and say, it's not possible for me to produce another COVID-19 vaccine, that the other one is 90% effective. Can't I get another one that will be more than 90%? If effectiveness will be more than 90%. The person can start analyzing, okay, after producing a drug, it would experiment, or the person that produced the drugs will give it to an analyst. Say, can you help me test the efficacy of this drug and prove scientifically that this my drug is performs better, is more effective than the previous COVID-19 vaccine? In this case, what they are working with is proportion. They are working with proportion of those cured. So the proportion for the first drug is 90%. So what the person would do, the analyst would do is they will administer the new vaccine to people, and he will observe the number of people that will be infected. So let's say after administering the COVID-19 vaccine to different set of people, only five were contracted COVID-19 again. It means it is 95% effective. That means those that didn't contract, they are 95 out of the 100. So it is 95% effective. Why the other one is 90% effective? Because we're talking about proportion now. Now, what we'll do is chi-square test for proportion. Chi-square test for proportion. Take note of the word proportion. When you're talking about mean, that's when you do. Sorry. What am I saying? Not chi-square, t-test. T-test, sorry, t-test test for proportion. Then when you are talking about mean, we'll talk about t-test test for mean. Before we continue, sorry for saying chi-square, please. It's t-test, not chi-square. Let me just show you some things on Minitab. Like I said, we'll be doing both of them simultaneously. So I just explained when we use, I'm trying to explain t-test. So I've tried to explain why we do t-test. You have one sample, you have two samples. So what I explained so far is for two samples. You are trying to compare the new drug that is more effective than the first drug. That is for two samples. Now let me use another example. I'm a producer. I want to produce fluorescent bulbs. But I discovered that there is a company called Omega, and Omega produces fluorescent bulb. But I did my test. I discovered that the lifespan of Omega bulbs, the lifespan is 120 days. That means after 120 days, they are likely to die. They are likely to get bad. You have to go and get a new one after 120 days. And I said, wow, so since I've known the lifespan of Omega bulbs, can't I produce my own bulb and prove scientifically that, statistically also, that my bulb is better than Omega bulbs? So what I'm trying to do is I'm comparing the mean lifespan. Then I will produce my bulb, give it to random people to use, and tell them to count the number of days that the bulb will last. So the first person came and told me he used the bulb for 250 days. The second person came and told me use the bulb for 220 days. The next person 230 days, 240 days, 243, 242. At the end of the day, I will then calculate the mean. So what I'm using now, what I'm doing now is what? T-test for mean. T-test for mean. What I explained before was T-test for proportion. The T-test for proportion was I used COVID-19 because we're talking about proportion of people that didn't contract COVID-19 again. But now I'm talking about lifespan, and the lifespan I'm talking about, we calculate the mean of all the lifespan. So in this case, we talk about T-test for example. For a two sample, I've given an example already. When you have an existing company, you want to produce yours and you want to show that yours is better. You have two groups. That's the basic, simple, the basic explanation for it. You have two groups. Let's say you have male and female, but you have two groups. That's the simplest way of explaining it. Two groups. And you are trying to compare to check if there is any difference in the two groups. And also if the difference is significant or not. But for one sample, let's say I'm making a claim. I'm producing my drug and I'm making a claim. I'm not comparing my drug, my bulb with another company. I'm just making a claim. What's the claim? I'm making a claim that this bulb I'm producing, the lifespan is 400 days. That's a claim. So because I'm making a claim that the lifespan of my bulb is 400 days, I'm not comparing it with any other bulb. So it's one sample test. So you have to do that. So let's start with that. Let's start with this test. One sample for t-test. One sample for t-test. Okay. I want to simulate data. This is not part of our course. Just want to simulate data. Simulate 100 data. So let's say I produce 30 or 50 bulbs. So let me use 20 bulbs first. 20 bulbs. Store it in column C1. Okay, let me explain what I don't want to explain this thing now. Later I will do it. Random data, but you can just look at what I'm doing. I'm generating from a uniform distribution. I want to generate data for 20 rows, store it in C1. That means store it in the first column. What's the lowest number? Lowest number can be, I'm making a claim that the lifespan of my bulb, the lifespan is 250 days. So the lowest, I want the lowest to be between 180 to 300. So I want random numbers, okay? So look at the random numbers. So let's carry out a test. One sample t-test. One sample t-test for mean. When do we use it? Someone is making a claim and it has to do with mean, not proportion. Proportion talks about frequency. When you're counting number of people that have a particular variable of interest over the total, you know it's proportion. Proportion has to do with what? Frequency, counting. But when you're not talking about frequency counting, you're talking about the mean. We use one sample test for mean. One sample test means we are considering one variable and they are making a claim that this variable is equal to a particular value. The claim now is that the lifespan is equal to 250. So you want to test it, you go to start basic statistic. Now you decide, is it one sample Z or one sample T test? We use one sample Z when our sample size is more than 30. We use one sample T when the sample size is less than 30. Though, if you know the population variance, like as I've taught those that I'm teaching in photo, If you know the population variance, you can use z-test, whether the sample size is less than 30. So let me explain again. If the population variance is known, use z-test, irrespective of the sample size. You already know the population variance and you know that it follows a normal distribution. Use z-test. But if the population variance is not known, you then ask two questions. Is the sample size less than 30 or is it greater than 30? If it is greater than 30, you still use z-test. If it is less than 30, you use t-test. Very simple. So in this case, I'm not going to use z-test. I'm going to use t-test because my sample is 20. I'm not going to use two samples because I'm talking about one variable, my own company. I'm not comparing it. So I will click the variable. I can decide to give it a name. The name is the lifespan. Santos left. Okay, lifespan. So I come to start basic statistic. Santos, you're welcome. You left us.
It's our network.
But is it okay now?
Not yet, sir.
Okay, you watch the recorded video. So one sample t-test. So you click this lifespan. I'm using Minitab now. You then click this. What is my hypothesized mean? I'm saying that the lifespan is 250. If you want graph, you click. Let me click box plot. Let me just click all and see. You then change your alternative hypothesis. Now take note. In Minitab, it will give you the option to select alternative hypothesis. SPSS doesn't give you that. SPSS is fixed to not equal to. If you want less than or greater than, you'll be the one to do the calculation yourself. SPSS, any analysis done on SPSS, the alternative hypothesis is always not equal to. In Minitab, most times, it gives you the opportunity to select, is it greater than, less than, or not equal to. So now let's use not equal to give you opportunity to select. Both of them, SPSS and Minitab, will give you the opportunity to select your level of significance. But SPSS doesn't give you opportunity to select alternative hypothesis. But there's a way to do that. You calculate it yourself. Okay. So look at the box plot. Let me cancel this. I don't want it. I don't want this. Okay, let me explain something. Let me redo the analysis and explain something. I've taught you box plot, what to use box plot for. This box plot is showing that there is no outlier. If the assignment I gave to you guys, after you did your box plot for chemistry, you discover that there is a point after this, after the box plot, there is a point outside the box plot that shows that there's an outlier. So this is showing that there is no outlier. So if you want to interpret it, it shows that there's no outlier. But we're not doing this. We're not doing this. We're not doing this. So this is the simple test. One sample me. You copy it. You can copy this first and paste. Then you copy the second one. It depends, like I told you, if you want to copy it in a table form, it's chatting. So I would download, okay. If you want to copy it in a tabular form, then you have to copy it to Excel first. Copy to Excel first. Okay, no problem, Santos. So we'll copy to this. You copy to Excel first before you copy to Word. You can put your table here, or you put your table when you move to Word. Your choice. So I can decide to put my table now. Up, bottom. Then I highlight this. I put top. If I want to do the alignment, I highlight, I click layout, and I align. Correct. So let me go back to this. This is not, it didn't copy well. Something is wrong here. Look at this. Something is wrong. I have to arrange it. This thing is for mean is standard deviation is 7 point, no, 32.36. Okay, we have XE mean 72.4. So this mean is supposed to be here. So that's why when you move to Excel, sometimes it doesn't copy well, so you arrange it. So this, then I have to merge this. Merge this, we move to this. So you see, sometimes you copy and it doesn't copy well. You have to ensure that it's going to copy well. So you see, one of the benefits of SPSS will bring the results in a tabular form, but Minitab doesn't do that. So Minitab, you have to move to Excel to convert to a table before you move to your Word. So I've arranged it. I can delete this column. The last column is no longer needed. So look at the p-value. So the p-value means we are not going to reject my null hypothesis. So you also write it the same way I wrote this. You write it. I'm testing the hypothesis. If you watch it, look at so you just follow the same pattern. You test the null hypothesis. We are not going to reject the null hypothesis because the p-value. So let me just say the interpretation. So I will start with the mean. The average, I'll start with the sample. A sample of 20 bulbs we are taking from my company, and the mean lifespan of the bulbs were calculated, which is 237.74 days with a standard deviation of 32.36. I can delete this. Like I told you, don't just copy all results. Not everything is needed. If I want to interpret this, I can say the 95% confidence interval is 222.59 and 252.88. This means that this interval will contain the actual value or the true value of the lifespan of the bulb produced in my company. Let me say it again. When we talk about confidence interval, how do you interpret confidence interval? Confidence interval is tells us that the interval will contain the true value of the parameter. So it means the actual value or the true value of the lifespan of my bulb is between 222 and 252. So any claim I make that falls within this interval will not be rejected. But if I make a claim outside this interval, it will be rejected. Very simple. So 95% confidence interval tells us that the actual value of the parameter will lie in that interval. So any claim I make within that interval will not be rejected. So I started my interpretation with the sample size. 20 bulbs we are used for this analysis that gave us an average lifespan of these days with a variation, standard deviation of this, full stop. The lifespan The average lifespan has a 95% confidence interval of this and this. This tells us that the true value of the lifespan of bulb produced in my company should be between this and this. Then I continue. My claim that the lifespan of bulb produced in my company is 250 was tested using the one sample t-test. If I want to tell them the reason why I use one sample t-test, I can go on. The one sample t-test was selected because the sample size is less than 30. Then you continue, you state your decision rule. The null hypothesis is rejected if the p-value is less than 0.05. Then you state your conclusion. I conclude that the null hypothesis is not rejected since the p-value is not less than 0.05, and I conclude that the mean lifespan is not different from 250. Very simple. The same thing I did in the previous interpretation. So always give a detailed interpretation. So I think we are going to stop here for today. We have done one sample. Okay, let me do the same analysis using SPSS, then we'll stop. So I can copy this data and move to SPSS. Let me create a new sheet for that. So I'll go to analyze, compare mean, one sample t-test. Okay, she that I've seen your end. You move to this. You change your value here to 250 and you click OK. So this, I see in this case, please take note. This 95% confidence, she that I've seen your end. This 95% confidence interval is different from the one from Minitab. What is here is 95% confidence interval for the mean. What we have here is 95% confidence interval for the difference between the mean and the hypothesized mean. So there are two different things. What the interpretation I taught you guys that I said earlier is only for confidence interval for mean, not confidence interval for difference. The interpretation I said that the confidence interval contains the actual value of the parameter. That definition is only for confidence interval for mean, not confidence interval for difference. What SPSS gives to us is confidence interval for difference. That one has its own different interpretation. That's not what I've explained. So Shidera, you can ask your question. Maybe Shidera, you type if your place is noisy. Can you type? Or if it's not noisy, you ask. I can hear you. Eh? Can we do what? Can you type? Just type. Okay. Oyemachi, do you have any question?
No, sir. No, sir.
Okay. So you see, look at the interpretation. We use the p-value. Check the p-value, 0.107. Check the p-value. Are you seeing that they are the same? So use any software you want. Okay, I've seen what you typed. Okay, asking if we can do for 2 samples. Okay, before we close for today. Okay, so let's go on to do for 2 samples as our boss suggested. So let's say we have 2 companies now. I want to simulate data, Omega company. So Omega has been producing bulbs, calculate random, still go from uniform distribution. So change this to Omega, but it should not be more than 250. This can go down to 150. So I've simulated the same data. Okay, let me see what is. I'm outside. They are already calling me to come back. Okay, no problem. Oyemachi, I've seen what you say. We are going to end now in the next maybe 5 to 10 minutes. So we'll go to now. We have to, like I've explained, for two samples. That one, when we talk about two samples, it means you are comparing. For one sample, you are not comparing. You just made a claim and you have a hypothesized value. While for two samples, you are comparing if two variables, two population, two samples are similar or not. So you go to start. We'll end this meeting in the next 10 minutes. So you go to start basic statistic, two sample t-test. Why am I using t-test? Because the sample size is less than 30. We don't know the population variance. So I'm going to use t-test. So look at this. I'm going to stop here. I'm not going to teach you how to do it in SPSS. Or let's see if we can do that. Now, Minitab has two ways of doing this. Minitab has two ways of doing this. The first one is that both samples are in one column, which is not what we have. So you have to select the second one, which is what? Each sample is in its own column. Each sample is in its own column. Then sample one belongs to lifespan and sample two belongs to what? Omega. Let me explain again. These both samples are in one column. That's what SPSS does. That's the only option in SPSS. SPSS doesn't have the second option. For Minitab gave us opportunity for two. Minitab gave us opportunity for two, which is what? Each sample is in its own column, or both samples are in one column. This is, like I explained, this is the only one SPSS has. Minitab has both. So let's use this. So this one means both of them are in different column. I will explain the other one before we end. So you click, you go to graph. Maybe if you want this, if you want it, maybe let's just click option. If you want to change your, remember I told you, Minitab will give you option to select your alternative. Then okay. We can use this to know if they are normally distributed, like I explained in our second class. This thing has to be at the center to show that it's normally distributed. It has to be at the center to show that it's normally distributed. So the p-value, look at the p-value, yeah? 0.00. It means the null hypothesis. Look at the null hypothesis. The mean, the average population mean for lifespan of my company and the lifespan of omega, they are equal. That's what we are testing. The difference is when you subtract. But the null hypothesis is that both of them are equal. The alternative is that they are not equal. That's what we selected. Then look at the p-value. P-value. It means there is a significant difference. Okay. Before I would state how you are supposed to interpret this, but let me do it in Minitab, in SPSS. So if you want to do it in SPSS, this is how you do it. You copy this. So let me copy my data. Copy. Let me go to SPSS. So I won't paste it here. I won't paste it here. This is not, SPSS won't understand this. So what will I do? I will paste it under this, but I will know that from this place, I will call all this 0. I will call all this, I will group them. They belong to group 0. Then I will paste it under this. I will paste it under this and call it group 1. So this is the first option that Minitab will give to you. This is what it means. Then I will come to this place and put the companies. Maybe I can put companies. Then I come to my value. 0 means omega. No, 0 means my company. My company. Y1 means omega company. So when you want to do t-test using SPSS, you can put the two variables on different groups, on different variables, on different groups. No, you put them in one variable. You put the two groups in one variable. Then you create a second, variable, a second column that you will use to group them. Just code it. You use the second variable to code it. The first group will belong to 0, the second group belongs to 1. Let me remove the decimal. Belong to 0, while the second group belong to 1. So this is how you arrange it. So I can do my analysis now. Analyze, descriptive. Sorry, compare me. To sample. You put the data, which is variable 001 here. Then this is where you put your group. Then it will ask you to change the group, to specify the group. We are using 0 and 1. Continue. That's all. I'm not going to interpret this for now. I want us to stop here so that I will not learn too many things. We'll stop here and continue tomorrow. We'll stop here because I have to explain equality of variance or this equal variance assumed. So we'll stop here. I'll send an assignment to the group. So far I've taught you what I explained fully. One sample t-test, chi-square for association and chi-square for equality. Then for 2 sample, I've explained it using Minitab, but the SPSS one, I've shown you how to do it. But I said for the interpretation, we'll continue tomorrow.
Yes, sir. Thank you, sir.
Okay.
Thank you, sir.
You're welcome. So I will send my assignment to the group chat and I will be glad if you guys can do it before tomorrow. I will send it now.
Okay.
Okay now. So let me stop sharing and let me stop recording. Chidera, you have a question again. You have to, when you ask a question, learn how to remove take your hand down.